Hello everyone, welcome to switispeaks official YouTube channel. My name is Sweetie Pinjani. This is UVM Basic series where we are learning basic UVM concepts from scratch. In case you have not gone through previous lectures in this series, I request you to please go through them because this is a continuation. If you want to understand this lecture, you should understand the lectures before this, especially the ones where we had covered about UVM object class and UVM field macros, because we are going to use those concepts in sequence item. Today, the topic is sequence item. Let's understand what is sequence item in UVM. One important thing which you should always remember is sequence item is an object class, not a component. We had discussed other classes in UVM like driver, sequencer, monitor. Those were components. This is an object. What is the main difference between component and object? Component is static. Static means it will stay throughout the simulation. Till the end of simulation, your component exists. And objects are dynamic. They will not stay till the end of simulation. They'll only stay until they are required. That is one of the main difference between component and object. In case of UVM, your sequence item is an object, not a component. It is called as data object because it contains the information about the data that is needed to drive your DUT. DUT is design under test. That's why sequence item is also called as data object in UVM. Sequence item inherits from the UVM object via UVM transaction. It means your sequence item is extending UVM transaction class, and this UVM transaction class in turn extends your UVM object class, which means indirectly your UVM sequence item is extending from UVM object via UVM transaction class. What does your sequence item contain? It contains data fields. This is the information which we need to drive the DUT. And also the randomization information, how these data fields are going to be randomized. You can create a user defined sequence item. How? By extending it from the UVM sequence item class. UVM sequence item is an inbuilt class provided by UVM. You can create your own user defined sequence item by extending from UVM sequence item. Now let us understand the class hierarchy of UVM sequence item. Say you want to create your user sequence item. As I said, that you can create by extending from UVM sequence item. This UVM sequence item is an inbuilt class provided by UVM. This is extending from UVM transaction, which in turn is extending from UVM object, which in turn extends from UVM void. This is the class hierarchy for sequence item class. Does your sequence item contain? As we have said, it should contain the information which is required to drive your design. What information do you need to drive your design? First, you need the information on data fields, then how they are randomized. The contents of your sequence item should depend on how to drive your design, the information which will be needed by the driver to execute a transaction on your design. That information you will need, and it can have various data property members, or we can call it as data fields. Examples are control fields. It contains the control information. For example, if you have a memory, there can be read operation or write operation. Whether the type of transfer is read or write, that can be an example of control information. Then what should be the size? whether it is 64-bit, 16 byte. This size information is also a control information. Next information which it can contain, the sequence item can contain, is payload. Payload is the actual data that needs to be transferred. Then comes the configuration information. Example of configuration information is mode of operation. In case you have multiple modes of operation possible, then what is the mode of operation for a particular simulation? If there are certain errors possible in your design, how those errors should behave. Then there is analysis information. Example is checksums. There are four types of data property members: control, payload, configuration, and analysis, which your sequence item will contain. How will you randomize your sequence item? We know that sequence item generates random stimulus. And what do you randomize? The data properties? Like whatever we had seen, what can be data property members? It can be control information, payload, configuration, analysis. You can randomize these. Now, the sequence item can be request or response. In case of request, you have to randomize it. Why? Because request is used to drive your design, and you need to provide a random stimulus to drive your design so that you can generate all possible types of scenarios. So, in case your sequence item is a request, that time your data fields, data properties should be randomized in, and this helps your design inputs to get a random stimulus. However, if it is a response means you don't have to drive the dut. In case of response, it should be non-random because you should not manipulate the response. The response should be as it is received. You should never ever touch the response. That's why in case your sequence item is a response, it should be non-random. Only the request sequence item should be random. Remember this. Why you want response to not be random? Because you don't want to corrupt the response by randomization. That is the main reason. How do you randomize the sequence item? By using constraints. We have a complete series on systemverilog randomization, which is uploaded on switispeaks official YouTube channel by Sweetie Pinjani, where we have discussed what are different ways to randomize your data. And there we had discussed different types of constraints also. Same concept we will use in UVM. We will randomize the data properties by using constraints. And most commonly used constraints are inline constraints. What are these inline constraints? Everything is discussed in System Verilog randomization series by Sweetie Pinjani. Please go through that. You will understand how to randomize in case you have not gone through. These are the main points while randomizing the sequence. Request should be random. Response should not be random. And how do you randomize the request? By using the constraints. Mostly inline constraints are used. And the constraints will decide the value of your properties, value of these data properties. It can be your data, control, all those fields which we discussed. And you should ensure that these values are valid. For example, your design requires a particular bit in memory to be always set to 1. Your constraints should say that that particular bit should always be set to 1 because your design says other values are invalid. You have to take care while coding the constraints so that only correct values are taken by the design inputs, because if you give incorrect values, then the output will not be correct. This is the caution which you have to take, and it should be within right limits. Say for example, only particular memory locations are valid for you, other memory locations are reserved, then those reserved memory locations should not be generated while randomization. This care also you need to take. This is very important question while randomizing. Why? Because if you give incorrect input, then you cannot expect the right output. Your design input should be correct for the design to work properly. That's why how you code constraints is very, very, very important. Take care of this. Next, let's see this UVM sequence item. As I said, it's an inbuilt class in UVM. How is it declared? As I said, UVM sequence item extends from UVM transaction. Again, UVM transaction is an inbuilt class in UVM. And it provides a lot of inbuilt methods. These are the methods. And the name of the methods itself is self-explanatory. For example, get sequence ID. It is the unique ID for your sequence. Then set item context, it will set the sequence and sequencer execution context for sequence item. Name itself is explanatory. Then set use sequence info. There is a use sequence info bit. You can set the status of that bit by using set use sequence info. If you want to get the value of that bit, get use sequence info will get the status of use sequence info bit. Then we have set ID info, which will copy the sequence ID and transaction ID from the referenced item to the calling item. Set ID info means sequence ID and transaction ID you need. Then set sequencer will set the default sequencer for the sequence. Your sequencer needs a sequence. So what should be for a particular sequence? There will be a sequencer. So what is the default sequencer for that sequence? That you can set using set sequencer. If you want to get the sequencer, use get sequencer. It will return a reference to the default sequencer used by your sequence. Then set parent sequence will set the parent sequence of the sequence item. What should be the parent sequence? Get parent sequence will return a reference to the parent sequence of any sequence on which this method was called. Wherever, for whatever sequence you call this method, what is the parent of that sequence? You will get a reference to that. Then set depth from your particular parent, whatever is the parent, how much is the depth of the sequence, and this is calculated automatically. Set depth is calculated automatically. And get depth will return the depth of your sequence from the parent. Whatever is your parent sequence, from that how much is the depth. Is item, it can be called either on sequence item or sequence. It will tell that this is the item. Get root sequence name will return the name of the root sequence. Root sequence is the topmost parent sequence in your simulation, whatever is the topmost sequence. Get root sequence name, this will return the name, and get root sequence will return the reference to the root sequence. This is the difference between these two methods. As I said, the name itself is self-explanatory. Then get sequence path, it will provide a string of names of each sequence in the full hierarchical path. Whatever is the name of each sequence you can get using get sequence path. These are various methods in sequence item. We are going to use it while coding. That time it will be more clear. For now, you can just remember how much you can. And as I said, the name itself is self-explanatory. Now let's understand one very important thing. If I want to create a user-defined UVM sequence item, what are the steps which I have to follow? The first step, of course, to create a user-defined sequence item class should be you have to extend using UVM sequence item. Then second is you need to define the data property members. What are the data property members? Control information, payload, configuration analysis, whatever you need, you have to define those property members. Then define the macros. We had talked about the macros in UVM object, if you remember. There we had talked about utility macros and field macros. And since your UVM sequence item extends from UVM transaction, which extends from UVM object, all the methods inside UVM object, all the macros inside UVM object can also be used in your UVM sequence item. We will use both the field and utility macros. In case you have not gone through, go through that lecture in UVM object and this UVM field macros. There we had discussed this in detail. What are different macros inside the UVM object? There will be utility macros and there will be field macros, which we will use in UVM sequence item. Then you have to call the constructor. The constructor is new, and then specify the randomization information in form of constraints. These are five main steps. First, create user defined sequence item class. Then define the data property members, define the macros, call constructor, and specify the randomization information. Now let us see this with the help of the code. I have a sweetie sequence item class which extends from UVM sequence item. Then there I have certain control information. For example, I have 16-bit address. I have write enable bit. I have read enable bit. Write enable is when you do write operation. Read enable is used when you do read operation. And then you have write data. This is the payload information because it contains your write data. And then read data is analysis information because it is output of the design and you use this read data to perform certain analysis. That's why it's a part of analysis information. I don't have configuration information in my code. In case you have configuration information, you can specify that also. Then we need to use macros. As I said, there are two macros, utility and field macros. In case of object, you have to use object utility macros. That is UVM object utils begin, and inside that you will pass your sequence item name, which is sweetie sequence item for me. This is the utility macro. Inside that, I am specifying the field macro. For example, I have address. So this address should be on for all properties. Now see, this syntax we have discussed in detail in UVM field macros. That's why again and again I am telling you, please go through that UVM field macros because then only you will understand this code. So in short, what this will contain, UVM field macros contains, first is your variable name, which is address, and then for what operation it should be on. If UVM all on, it means it should be on for all operations. This is the flag. It means address can have all operations. It can be compare, copy. All operations are possible on my address. And it is of type, and here I am using int because for me it will be int. That's how I am perceiving my address. That's why I am using UVM field int macro. Then similarly for write enable also, I am using UVM all on. Similarly for read enable, similarly for write data and read data. These are my UVM field macros. And then UVM object utils end. Inside UVM object utils, you have your UVM field utils. This also we had discussed in detail in UVM object and UVM field macros tutorial. Then once you specify your macros, which are utility and field macros, next you have to call the constructor new. In case of object, the new takes only one argument, which is name. For me, UVM sequence item is an object. That's why my constructor new takes only one argument, which is name of my object. What is name of my object? Sweetie sequence item. Then I am calling super.new, passing the name, and Then the constructor is called, and finally I'm specifying the randomization information. One important thing is read and write operation should not happen simultaneously. That's why when you have read enable, write enable should not be there, and vice versa. This is the constraint on read enable and write enable. Your write enable is not equal to read enable and vice versa. Then say my design requires that the MSB bit of the address, which is bit number 15, should always be 1. That also I am specifying in the form of constraint. That's it. For my class, I just have this much code for the sequence item. This will give you an understanding of how to code the sequence item. Then depending on your requirement, you can modify the code. Quickly, I will revise. First step was to define the user defined class that will extend from the UVM sequence item. Then you will give different information for the data fields. For example, control information. Your control fields are address, write enable, read enable. Here you know whether the operation is write or read. Then what is the size for your address. Then in payload, you have the data, and in analysis, whatever output from the design you want to analyze, that will come in the analysis information. Then you have utility and field macros. Field macros are always enclosed between the utility macros. Since UVM sequence item is an object, we use UVM object utils begin and UVM object utils end. And inside the object utils, you specify the name of your sequence item. And then field macros contains two arguments. First will be the name of your variable, and second is for what operations these variables will be on. In my case, I am keeping my variables on for all operations, means all sort of operation, copy, compare, and whatever is possible that can happen on my variables. And then you have to call the constructor new. Since it's an object, there is only one argument, which is name of your sequence item. And then you have to provide the randomization information. One important thing, read and write should not happen simultaneously, and in your design it is a requirement that MSB bit of address should always be 1. This is your sequence item code. Now quickly let's summarize whatever we learned. We learned that sequence item is a data object in UVM because it contains the information about the data which is used to drive your DUT. Then it inherits from UVM object via UVM transaction class, which means your UVM sequence item extends from UVM transaction, which in turn extends from UVM object. Then the UVM sequence item contains data fields and randomization information. Data fields can be control fields, like whether the operation is read or write transfer, then what is the size. Then there can be payload information, which is data. Then analysis information, for example, if you are reading the read data from the design and you want to analyze it, it will be a analysis information. And if you have any configuration information, like what is the mode of operation, that kind of information is also a data field. Then randomization information, how those data fields should be randomized. For example, read and write operation should not happen simultaneously. That can be one randomization information. Then what are the steps to create your UVM sequence item? 5 main steps. First one was create a user defined sequence item class which will extend from UVM sequence item class. Then you have to define the data property members, which can be control information, data, which is the payload, then analysis information, your configuration information. Then you have to define the macros, which will be utility macros and field macros. Field macros are always enclosed inside utility macros. Since sequence item is an object, you will use UVM object utils macros. And then you have to call the constructor new. Since it's an object, it will take only one argument, which is name, and then specify the randomization information. This is how you can create a user defined sequence item. This clarifies the sequence item, which is an object inside your UVM. We had covered a lot in UVM. Please revise all those concepts in case you want to go through all these lectures, go through again, because now slowly we are going to move towards advanced concepts in UVM, and I want everything to be clear. That's why please revise. If you want to go through these lectures again and again couple of times, please go through. I want all these concepts to be clear, so that now when we start advanced concepts you are not confused. That's why I'm covering each and every topic in depth. Please revise, and stay tuned to Sweetie Speaks official YouTube channel, because there is a lot more we have to cover, and I want to cover everything in depth, and I'm sure you also want to cover everything in depth. So I, Sweetie Pinjani, will see you in the upcoming lectures. Thank you.